Today we're learning about the fourth and final transformation of this unit, and it's called dilations. So you can use a scale factor to make a larger or smaller copy of a figure that is also similar to the original. And if you look at this model over here, you can see that we have a center point, a smaller figure, and a larger figure. But both the smaller and the larger figure are the same shape. Because dilations change the size of the shape, this is not a rigid motion. And you're going to see a question like that on the quiz that asks what all your rigid motions are. Note that dilations are not rigid motions. So dilations are controlled by a scale factor, which makes the pre-image either smaller or larger. And the scale factor is found by, or is represented with a variable n. The numerator of your scale factor is going to be the image length, and the denominator of your scale factor will be the pre-image length. And you'll see what I mean by that when we start to go through the examples. There's two options with dilations. You could have an enlargement, meaning the figure gets bigger, or you could have a reduction, which means the figure gets smaller. If you have an enlargement, that's telling you that the scale factor is greater than 1, meaning n is larger than 1. If we look at our model in this box, you can see that the original figure is the smaller figure here, and the larger figure is the figure using prime notation and is the figure I just highlighted in green. So when you're finding the scale factor, you're going to use the formula given above, which says it's the image length divided by the pre-image length. And we're going to find that here. So the scale factor, represented with n, is going to have the image length. And you, of course, want to use corresponding sides, so the same side but on each figure. So the image length is going to be this number 4. So CD, side CD, is the side we're looking at. And the pre-image length, or the denominator of this fraction, is also side CD, same side. The length is 2. If we simplify this, our scale factor n is equal to 2. That means that the figure, the smaller figure, the pre-image, is enlarged by a scale factor of 2. If we look at a reduction is telling you that the scale factor is between 0 and 1. Our pre-image, or the original image, is this larger figure. The image after the dilation is the smaller figure. And if we're looking to find the scale factor, we use the formula of the image length divided by the pre-image length. And you, of course, have to make sure you use the same or corresponding sides. So your corresponding sides, your image length of 2 and your pre-image length is 8. So your scale factor is going to be 2 divided by 8, which is equal to 1/4. So the scale factor of n is 1/4. And that indicates that the pre-image went through a reduction to end up at the image size, meaning the pre-image got smaller. Okay, so going through the next few examples, let's grab our formula. The first example says, is triangle x prime, t prime, r prime an enlargement or reduction of triangle xtr? And what is the scale factor n of the dilation? I'm going to highlight my pre-image in purple. I'm going to highlight my image in green. So is the image smaller or larger than the pre-image? Hopefully you all know that the image is larger, so therefore it's going to be an enlargement. We can get rid of C and D. Those both represent reductions. And in order to find the scale factor, you set up a ratio of the side length of the image divided by the side length of the pre-image. Just be careful because the numbers that are given to you are 8 and 4, but the length of this green triangle is that total length, which is 12. So be careful. Notice, precisely notice where the segments are marked. Okay, so the scale factor is going to be the image length of 12 divided by the pre-image length of 4. 12 divided by 4 is 3. That's telling us that this is an enlargement with a scale factor of 3. Looking down at this section, it says you can find the dilation of a point by multiplying the coordinates by the scale factor of n. So if you were to use a notation, you would say x comma y maps onto your scale factor of n times x, and then your scale factor of n times y. Finding the dilation of an image when the center is at the origin. That's a big one to pay attention to because eventually we will be doing them not at the origin. But the center at the origin is the center here, meaning everything is going to shrink or expand from that point. Number 1 says to graph the dilation of the following figure by the scale factor of 1/2 and the center of dilation at the origin. What are the coordinates? So I'm actually going to set up a table of my original points and then my new points with a scale factor of 1/2, meaning I'm multiplying both my x and y coordinate by 1/2. I'm going to list each point. I'm going to start with point Z. Point Z is located here. Point Z is at -2, 2. And when you apply the rule to it, Z prime is going to be at 1/2 times 2 times -2, and then 1/2 times +2. When I simplify this, Z prime is going to be at -1, 1. I'm going to plot this point in blue, and that point is located right here. Next, let's look at point G. Point G is located at 0, -2. Point G prime, I'm going to do this one in my head. 1/2 times 0 is still 0, and 1/2 times -2 is -1. G prime is at 0, -1. And the last ordered pair, point P, located at 2, -2. When you apply your transformation rule, the new point is at 1, -1. When I connect these points, this is going to be my image. And this image just got smaller with respect to the origin. So it was a reduction, smaller size. Because the center is at the origin, it is moving in towards the center, meaning every point is heading towards the center. The figure is becoming smaller. Next, we're looking to determine the scale factor. There's many different ways you can do this. You just have to recognize which figure is the pre-image and which figure is the image. That's the biggest thing, or that's the biggest mistake students make, is they just don't pay attention to which one is which. So purple right here is your pre-image. I know that because of the notation. And your image is this green highlighted figure. And I know that because, again, of the notation, the prime notation. So what you could do is you could count the distance from the center. You could figure out what the multiplier is, but you could also take a look at the ordered pairs, which I think is what I would do. And most likely I would do this in my head. So this ordered pair right here is at 0, 2. And this ordered pair is at 0, 4. So I recognize to get from the pre-image to the image, I could multiply that by 2. So times 2. And I would check that for all points. So point B is at 2, negative 1. And point B prime is at 4, negative 2. So just think, all right, if we multiply our pre-image point by 2, looking at your x value, 2 times 2 is 4, so that works. Looking at your y value, negative 1 times 2 is negative 2, so that works. And just looking at point C and thinking about that in our head, negative 2, multiply that by 2, you would get negative 4, negative 4. So on this first one, on the only one here on your note sheet, the scale factor, n, is equal to 2. And I'm just going to make a note that this is an enlargement. Again, there's a few ways you could go about doing this. Most likely you can look at it in your head and you can think about these values. But if you need to make some notes out, you could do that. If you want to take all of this and you want to put it into an organized table, you could do that as well. Whatever you need to do to identify what the scale factor is. The reason why I didn't look at the side length is because you can't count the side length of this triangle in order to determine what it is. That side length is a diagonal in the coordinate plane. So when it's not given to you, it is difficult to determine the side length. Okay, next we're looking at when the center of dilation is not at the origin, so when it's not in the center of your coordinate plane. And when you are working with problems like this, you need to use the rise and run technique. It's very important. Now you can do some of this in your head, but you absolutely have to use the rise over run. It won't work any other way. So to dilate by a scale factor of 2, you would double the distance. You double the distance of the rise and run from the center of dilation. This first problem says to draw dilation of a quadrilateral ABCD, this figure here, using the point P at 2, 5 as the center of dilation and the scale factor of 3. So I'm going to mark point P at 2, 5, located here. And just, you might want to pay attention to how I do this and then come back and take the notes. But what I like to do is I like to draw a line through P to A, and then I'll continue that. I'm going to make this a dashed line. Actually, you know what? I'll make it a solid line. I'll just make it very thin. And that way we can easily see what the slope is. So I'm going to go like this, straight through that point. And I'm just going to extend this a little bit further. I'm going to count my slope. So slope is rise over run or fall over run if you're going down. So from point P to point A, we're dropping 3 units and we're running 2 units. If the scale factor is 3, we need to do that 3 times. So that would be the first time we just did the slope. That's down 3 over 2. I'm going to do this 2 more times. Down 3 over 2. That would be the second time. Down 3 over 2. That is the third time. I'm going to plot a point. That is point A prime. And it should be on that pink line that I drew. That pink line is not part of your answer. It's kind of just a guide to make sure that your slope is correct and that it is in the correct location. So again, we counted the slope, meaning we went down 3 over 2. And because the scale factor is 3, that's what the directions say, we repeat that 3 times. And that is the point of A prime. Okay, I'm going to erase all of our work so it doesn't clutter up our graph while we're doing the same thing for the other points. Next, I'm going to do point B, draw a line, through point P and B, and I'm going to continue that. I'm going to count the slope, which is down 1 over 2. That's the first time. Repeat this 2 more times for a scale factor of 3. And point B prime is located here. Again, make sure it's on that first line we sketched. Make sure it's in line with your original point or your original center of origin. Repeat this process with point C. Point C is actually a straight shot, so from P through C, that's a straight line. So let's just count the distance down to point C. We have 1, 2, 3, 4, 5. That's going to be the first one. We're going to repeat that. So 1, 2, 3, 4, 5. That would be the second. And then 1, 2, 3, 4, 5. So point C actually ends up being right here at the bottom of the graph. That's C prime for our image point. And our last point is point D. Draw a line from P through D. Count your slope. We are going down 3. We are going over 4. So repeat that again. Down 3 over 4. Down 3 over 4. And this is the location of point D prime. Once you have your points, we're going to connect them for our image. And this here is your final answer. Okay, so if you look at my note sheet on my website, if you download like the handwritten notes, you'll see that I wrote out all of this work. So I wrote out my slope, I wrote multiplying it by 3, I wrote how we're gonna find it. Feel free to check that out if you'd like to see the mathematic way to find each one of these points. I do find it to be a little bit longer, and ultimately you're still counting in the coordinate plane. So the fastest method for using or finding a dilation when the center is not at the origin, I believe, is this method. But again, feel free to check out my note sheet if you want to see the handwritten math work out. And we have one more example, which is going to be a scale factor of 1/2. So this is going to be a reduction. Number 2 tells us to use the point of P at 4, -2 as our center. So 4, -2 is located here. And we are looking at a scale factor of 1/2, which means we are actually going to be dividing our slope in half. So from point we're going to start with point A. We're going to draw a line straight through that. I'm going to count the slope. So let's count what the slope is from P to A. And the slope is typically rise over run. So for this one, we're going to be rising up 1, 2, 3, 4, 5, 6 units. And we're going to be running 1, 2, 3, 4, 5, 6, 7, 8 units. So we're looking at up 6 and then over 8. If we divide those numbers in half, we would be going up 3 over 4. We're dividing them in half. 8 divided by 2 is 4, 6 divided by 2 is 3. So if I go up 3, I'm re-highlighting in purple, up 3 units over 4 units. That point would be located on our pink line. So that's what we're checking for. We're checking to make sure that it ends up on this line we just sketched. And it does. This is going to be point A prime. And you're going to do the same thing for every point. So let's do point P through B. The slope to get from P to B is up 2 over 1, 2, 3, 4, 5, 6. So plus 2, up 2, and then over 6. If we divide each of those numbers by 2, 6 divided by 2 is 3. 2 divided by 2 is 1. That means we're going to be going up 1 over 3 for our new point. Up 1 over 3. Make sure it's on that line we sketched. It is. That is point B prime. Again, when I'm talking about the line, I'm talking about this one. And from P through point C gives us a slope of 4 over 2. 2 divided by 2 is 1. 4 divided by 2 is 2. I'm going to go up 2, going to go over 1. That's going to be point C prime. I have my 3 points. I'm going to connect them for my final image. And that is my final answer. So most of this work you can do in your head. I'm sure that you can. So you can divide those numbers. They're going to be very basic. So either multiply or divide them by whatever number you need to. In this case, it was 1/2, and it gave us our final answer. Again, you can do your work off to the side, but what I'll be checking for is your image in the coordinate plane. Because I know that you can do this work in your head, I will not be checking for work, like separate work in a table. I'm just looking for that answer. Okay, and the last example on the note sheet is finding the scale factor in the center of dilation. So we're actually going to go about this just the way that we've been doing the other ones. I'm going to be sketching lines in the coordinate plane. So I also want to point out that we are talking about figure A, B, C, D, and E, F, G, H. So I didn't use prime notation on these two figures. And that's completely okay because you know that the first letter, or you should know that the first letter of each figure corresponds to one another. So point A corresponds to point E. If I connect point A and E and I just continue a line through them, I'm just going to do that for all points and I'm going to see where they meet. And then let's check the slope and see if the slopes work out. So point A through E. Next, I'm going to look at point B and F. Next, let's look at C and G. And lastly, let's look at point D and H. So all of these points intersect at one location, and it's the location located where I just put that green point, or right here. That's going to be your center of dilation. So we did that by looking or by drawing lines using the slope. This point is at 5, -5, -3. The next part of this asks us for the scale factor. So now let's use our slope to find the scale factor. And I'm just going to do this on, let's do point A through point E. So from the center to point A is up 2 over 1. Do that again, up 2 over 1, up 2 over 1. We just did this 1, 2, 3 times. So the scale factor is 3. Let's check that, make sure that we are correct. Let's check it with the blue line. So the blue line is point B to F. So from our center to point B is up 2 over 2. We're going to go up 2 over 2, up 2 over 2. That works 3 times for our scale factor. We count the slope, that gives us our scale factor, and it also gives us the answer that we're looking for. So the answer for this problem is not only the center, but it's also the scale factor. Okay, please complete the Go formative for today. Let me know if you have any questions. Tomorrow's class is going to be partially a review and partially composite transformations. However, composite transformations are just multiple transformations put together. So it might be like a translation to the left one, and then you reflect it over the x-axis, something like that. So composite transformations are just a bunch of the transformations put together. Your CCA is actually the next quiz, which is not tomorrow, but it is the day after. So tomorrow will be used as partially a review day. We'll be doing quite a bit together during class. And then the following day is a quiz, and it will also count for your CCA. So please make sure you are asking questions, you are fully understanding all of this material, and you let me know if you need any help.